Bismillahirrahmanirrahim. Today we will discuss some problems regarding vector additions and multiplication of vectors, scalar and cross products. Firstly, consider this problem in which vector A and B are given. For I minus 3j plus k, vector B is minus I plus j plus 4k. There are three parts in part A. We have to find A plus B. In part B, we have to find A minus B. In part C, we find the vector C such that A plus B minus C equal to 0. Firstly, we found the part A plus B equal to, just put the value of vector A, which is 4i minus 3j plus k, plus, after plus sign we put the value of vector B minus I plus j plus 4k. Open the brackets. 4i minus 3j plus k plus minus I plus j plus 4k. Here there are two terms of the two terms of the I. Similarly, there are two terms of the j and two terms of the k. We first take the I terms and their coefficient must be added. Here the coefficient of 4 I, first term of the I is the 4 and the next I term is the minus 1. So their coefficient must be right in bracket and take I as a common. Next we take the coefficient of the j, that is minus 3i plus 1j as a common. Thirdly, we take the coefficients of k, which is 1 plus 4 and k as a common. The result is 3i minus 2j 5k. This is the result of A plus B. Next part B, A minus B. Again we put the value of A vector 4i minus 3j plus k, then minus sign, and after minus we put the value of vector B minus I plus j plus 4k. Keep in mind, firstly we put the value of A vector and then after minus we put the value of B. Don't change this order. Again open the brackets. 4i minus 3j plus k minus and minus plus I, this plus j, this minus sign change the plus j into minus I j. Again this minus sign change the whole sign changes the sign of the each term. This plus 4k become minus 4k. Again we combine the coefficient of the I, j and j, k and k, where the coefficient of I is the 4 and 1. Both are 4 plus 1 I. Next we take the coefficient of 3j, that is the minus 3 minus 1, plus again we take the coefficient of k, which is 1 plus minus 4k. The result is 5i minus 4j minus 3k. The part C, is to find the vector C such that a plus b minus c must be equal to 0. If we take the c toward the right side, then it can be written as a plus b equal to c, and c vector equal to r a plus b. As we already solved the a plus b, which is 3i minus 2j plus 5k. So the c vector must be 3i minus 2j 5k. Next problem is the show that the addition of vector is associative. A plus c equal to a plus b plus c. This is the associative property with respect to addition. We have to show that the left hand side equal to the right hand side. Consider the three vectors: vector A, vector B, vector C, and this is the R resultant vector of A, B and C. A, O, P, Q, R. Joining O with Q and P with R. On the diagram, OP vector representing vector A, PQ representing vector B, QR representing vector C, OQ and OR representing vector R resultant. From figure, OQ, this OQ is the resultant of OP plus or sum of OP plus PQ. And OP is the vector A and PQ is the vector B. This is equation number 1. Again, if we consider this vector PR, which is the sum of PQ and QR, as PQ is vector B and QR is the vector C. This is equation number 2. From the figure we can see that the vector OR is written as vector OR. This can be written as, if we consider OP and PR, OP, this one and this one. OR is the sum of, if we neglect this one for the time short or for this time, we can see that the vector OR is the sum of OP and PR. Where OP is the vector A and PR from equation number 2 is the sum of B plus C. This is equation number 3. Again, if we consider only OQ and QR, OQ and QR, OR is the sum of OQ and QR. So from here OR is equal to OQ is equal to, from equation 1, A plus B plus QR is the vector C. This is equation number 4. As we see that in equation number 3 and 4, the left hand side of these equation number 3 and 4 are the same, so their right side are also equal. This can be written as vector A plus B plus C equal to vector A plus B plus vector C. As this proved, the addition of the vector is associative. Next problem proved that find the projection of a vector which is I minus 2j plus k and on the vector B which is 4i minus 4j plus 7k. projection of A of A on B is A cos of theta. According to dot product of A and B, A dot B equal to cos of theta. From this equation, A cos of theta, which is the projection of A on B, can be written as the dot product of A and B divided by magnitude of B. Putting the value of A, vector A, which is I minus 2j plus k dot product with vector B 4I minus 4j plus 7k divided by mod of vector B 4I minus 4j 7k. In dot product we know that the only the terms which are multiplied with each other are the I and I coefficient j term with multiply by the j, and the coefficient of k will multiply by the k, because I dot j dot k and k dot I terms are 0. So the coefficient of I is multiplied by with the coefficient of I again is 4, and I dot I j dot j k dot k gives the 1, minus 2I multiplied by minus 4 give you 8, plus 1k multiplied by 7k give value 7, divided by under root square of 4 plus minus square of 4 plus square of 7. This gives you the 8 plus 4 12, 12 plus 7 19, under root 81 or 19 by 9. This is the projection of A on B. Next problem, find the force needed to prevent the this is the point P on which a force of 200 Newton is acting and a force of 150 Newton is acting horizontally, and third force of 100 Newton is acting vertically downward. We have to find the force to prevent the point P from moving. Consider 200 force as a F1, 150 force as a F2, and this one as a F3. Resolve this F1 into components. This component will be F1 y and this component will be F1 x. Again I will repeat this question. An object P is acted upon by three coplanar forces as shown in the figure. Determine the force needed to prevent P from moving. We have to find the force to prevent the object P from moving. Here there are three forces, 200 Newton, 150 Newton and 100 Newton are acting on this point P as shown in the figure. Firstly, we find the sum of all forces along x-axis. Here along x-axis there are two forces. One is the x component of force F1 and F2. Both are in the same direction though, so they are added and both are taken as positive. F1 x is the 200 cos of 30 plus F2 is 150 Newton. The result is 323.2 Newton. Next is the sum of all forces along y-axis, which is two forces F1y and F3. Both are in opposite direction. F1y is taken as positive, so F3 is taken as negative. F1y is the y component of 200 Newton, that is 200 Newton sine of 30 Newton minus 100 Newton. This gives the 100 Newton minus 100 equal to 0. The net force along y-axis is 0, while the net force along x-axis is not 0, which is 323.2 Newton. It means the object will move along x-axis with 323.2 Newton. So to prevent the object from moving in x direction, we must apply a force of 323.2 Newton in minus x direction. The rest of the problem I will give you on WhatsApp. Please see these problems also. And I will move on the next chapter, which is the motion in 2 or 3 dimensions. To describe the motion of an object in two ways. One is the mathematical way and the other is the graphically method. The mathematical approach permits more precision than the graphical sketch. However, we will adopt both mathematical and graphical methods. In describing the motion of an object, we will discuss some terms. Firstly, we will discuss the position. Position is defined as the location of a point. Let us consider a point P on the xy with coordinates A and B. The location of this point or position of this point is indicated by the coordinates A and B, which shows that the point P is located at A distance along x-axis and B distance along y axis. It is written in or represented, it is represented by vector r. Position of a point can be written as ai plus bj in two dimensions, or if the point is taken in three dimensions, that is the a, b and c, then vector r representing the position of point p is written as ai plus bj plus ck. Next term is the displacement. Displacement shows how much an object or point is displaced from its position or initial position. It can also define as displacement is the change in position. Let us consider an object initially at point A whose position vector is Ra, and after some time it moved to point B along curved path. If we joining from A to B and place an arrowhead at the B, from this diagram RB vector is the resultant of RA and D, or D can be written as RB minus RA. The right side of this equation number 1 representing the change in position. That means change in position is the position change in position is the change in position of the vector, that is the RB minus RA. Change always indicating the final term minus initial term, or final destination minus initial destination, where change in position means the final destination vector minus initial destination vector, where object is moved from A to B, so the final destination is the point B and the initial destination is the point A. The initial so change in position is the RB minus RA, which is equal to the D. So D is the again the this is the subtraction of the two vector, which gives again a vector quantity which is the D. So D is a vector which is indicating from A to B, which indicate the object is indicating from A to B in this direction, and the magnitude of this D vector representing the how much object is displaced from A to B. The unit of displacement is meter, and dimension is L. Next term is the velocity. Velocity is defined as how quickly an object changes its position, or we can define also at the as the rate of change in position with respect to time. It is represented by a V sign that is equal to d by t, where d is the change in position or displacement. Its direction is also along the displacement. So direction of v is in this diagram is along this displacement vector. Unit of velocity is meter per second, and its dimension is length time per time meter. Here is also another term, average velocity. Average velocity is defined as the ratio of total displacement to the time taken to cover this displacement. It is represented by V average, that is equal to A d by t. In this diagram, arrow this arrow vector representing the V average velocity. The V average velocity does not give information about the path, whether it is a curved path or a straight path, So we will move toward the instantaneous velocity, uh, which is defined as instantaneous velocity is the limited value of the average velocity. It is the limited limit of the average velocity as delta t approaches to 0. Its direction this was the v average velocity, and the instantaneous velocity at point A is the tangent line at that point on the curve. So the v instant is different from the v average. It can be written as v instant equal to the limit delta t approaches to 0 d by delta t. Next is the acceleration. It is the rate of rate of change in velocity, that is a, where a indicating the acceleration, that is delta v by delta t. Its unit is meter per second square, and dimension is length time minus 2. There are further types of acceleration like velocity, average acceleration, instantaneous acceleration. Average acceleration let us consider again velocity at this moment is vi, and at some later moment is vf. We can replace this vf here such that its direction and magnitude does not change, and joining the head of these two velocities vf and vi, which indicate the delta V means Vf minus Vi. Change in velocity means Vf minus Vi. So the average acceleration is representing the overall change in velocity per unit time, that is delta V by delta T. Its direction graphically can be seen that it is different from the direction of Vi. Here is in this direction. At that point the direction of velocity is in this direction, while the change in velocity is in this direction, and which is indicating the direction of acceleration. So the acceleration of an object may be in the direction of delta, in the direction of velocity, and in some cases it may not be in the direction of velocity. It is always in the direction of the change in velocity. एक्सेलरेशन की डायरेक्शन हमेशा चेंज इन वेलोसिटी की डायरेक्शन में होगी, और डेल्टा वी हमें फाइंड आउट करना होगा कि वो क्या होगा. अगर लीनियर मोशन होगी, अगर ऑब्जेक्ट क्या कर रहा हो, स्ट्रेट लाइन में जा रहा हो और उसकी वेलोसिटी क्या कर रही हो, इंक्रीज कर रही हो, तो वेलोसिटी की डायरेक्शन डिस्प्लेसमेंट के अलॉन्ग है, और एक्सेलरेशन की भी डायरेक्शन क्या होगी, डिस्प्लेसमेंट के ही अलॉन्ग होगी. अगर वेलोसिटी क्या कर रही हो, इंक्रीज होगी, यानी कि डेल्टा वी में चेंज पॉजिटिव आ रहा हो. अगर डेल्टा वी पॉजिटिव चेंज है तो इसका मतलब वेलोसिटी इंक्रीज कर रही है, तो वेलोसिटी ही की डायरेक्शन में एक्सेलरेशन भी होगा. और अगर आपके पास उस केस में हम कहेंगे कि एक्सेलरेशन क्या है, पॉजिटिव है. और एक्सेलरेशन नेगेटिव भी हो सकता है कि अगर आपका ऑब्जेक्ट की डिस्प्लेसमेंट क्या हो, इन दिस डायरेक्शन, वेलोसिटी की भी डायरेक्शन यही होगी, लेकिन वेलोसिटी की डेल्टा वी की जो डायरेक्शन क्या हो वो अपोजिट हो. वो किस केस में हो सकता है कि आपके ऑब्जेक्ट की आफ्टर जो जो मूवमेंट हो रही है तो उसकी वेलोसिटी जो है वो कम होती चली जा रही है एज कंपेयर टू दी अबव केस. वहाँ पर क्या हो रही थी कि फाइनल वेलोसिटी अगर आप देखेंगे वो क्या होगी, ज़्यादा होगी इनिशियल वेलोसिटी के, लेकिन इस केस में आपके पास फाइनल वेलोसिटी एज कंपेयर टू दी इनिशियल वेलोसिटी कम होगी. तो इस केस में आपके एक्सेलरेशन की जो डायरेक्शन है वो अपोजिट होगी, opposite to the displacement or opposite to the velocity. So we always check the what is the direction of delta v. ये तो वो केस है कि लीनियर मोशन के, अगर आपके पास ऑब्जेक्ट क्या कर रहा हो, जैसे यहाँ पर हमने कहा कि वो कर्व पाथ में मूव कर रहा है, तो हमारे पास जो है ए की जो डायरेक्शन है वो डेल्टा वी डिफाइन कर रहा है, नॉट वी. तो एवरेज एक्सेलरेशन डायरेक्शन हमने देख ली, कैसे हम कैलकुलेट कर सकते हैं. अगेन अनदर टर्म इज द इंस्टेंटेनियस एक्सेलरेशन. Like instantaneous velocity, instantaneous acceleration is also the limit value of the value of average acceleration, such that delta t approaches to 0. That is a instant equal to limit delta t approaches to 0 delta v by delta t. That's it for today. Thank you very much.